I've always been fascinated by the little vortices that form when you drag your spoon through a cup of coffee or hot chocolate. So I was blown away when I saw Physics Girl's video showing the Vortex ring launched across a swimming pool. And I thought, I've got to do that myself. Now, if you haven't seen that video, I'd recommend you do. There's a link in the description below. Absolutely watch that. She has excellent graphics and does a beautiful job of explaining what's going on. I'm just going to show you how to scale it down in case you live in a winter climate like I do in Colorado and don't have access to a big swimming pool and certainly don't have a sun overhead to really show the dark spots that you'll see in her video. So I'm doing it in a plastic bin here. You can also do it in a cake pan if you don't have that. I'm using a spoon to launch. It's very important that you have a round surface. You'll see why when you see the graphics in her video. You're actually launching half of a vortex ring. What you see, and I'll do the little dipping here, you can kind of see in this video the depressions you get from the ends of the vortex ring as they intersect the air-water surface. But the best way to see them is to illuminate it overhead. So I'm going to turn on an overhead light bulb and turn off the room lights. And now, when I launch the vortex ring, you can clearly see the dark spots, just like the sun was causing in her video in the pool. This is caused by refraction of light. The surface of the water is being dimpled a little bit, and that causes light to refract, and less light actually hits the center of these two rings at the bottom of the pool. That's what makes it dark. As I say, her explanation is excellent, so by all means watch that video. But here you can see that it's very easy to do this in small scale at home without a pool. You can experiment with different sizes of spoons and different technique for dipping and dragging it. It's very important to pull the spoon out of the water gently to launch nice rings, and you can see you can get them to travel all the way across my little pool here. And with practice I can do even better. Of course, being on the spot right now, I'm not getting my best ones, but you can have a lot of fun with these. If you launch a large slow ring followed by a smaller ring, if I can get this to do it, you can see how one ring is accelerated right through the ring in front of it. There we go. A lot of cool things. Now, I haven't found a good way to reproduce the effect that she got by injecting food coloring into the vortex. It just doesn't work very well on a small scale. I think it's probably got something to do with the surface area to volume ratio in these much smaller vortices, which is also why they don't persist quite as long as the larger ones do in the swimming pool. But I have tried, and I am still experimenting, sprinkling some coffee creamer or something into the water to help you visualize the full half ring that you have under the water's surface. But one way you can indirectly see what's going on is to place a pencil, a little barrier. Now what this is going to do is this is going to disturb the ring as it goes by, and you'll see it just destroys the ring. Now, since this barrier is very narrow, a lot of times there's enough momentum still in the two pieces that the ring actually reattaches and reforms. That was a beautiful example right there. But you can see how that pencil is breaking up. It's actually intersecting the bottom half of the ring and breaking it apart. So this indirectly shows you that these two dark spots are really connected. These two vortices you see at the surface are really part of the full hemispherical ring. The other thing I can do to make that a little clearer, instead of putting the pencil all the way through the water, what I'm going to do is dip a pencil just slightly into the surface of the water. So it's just breaking the surface of the water, and what should happen is that our vortex ring should easily pass under that. And you can see it doesn't really bother. There's a little bit of a third vortex that's created because of the waves that I'm launching as I dip my spoon, and it's interacting with the vortex ring itself. So you get some interesting things going on. In fact, if we go back to our pencil in the water, if you look closely, sometimes you'll see a third dark spot emerge from the other side of the pencil. There's a little one there. Let's see if we can get a better one. Boy, these are reproducing themselves beautifully. Watch a little smaller one. There we go. So there's a lot of things here to investigate and experiment with. But anyway, I hope you have fun experimenting with this at home. You can try this in your bathtub even, and have fun with it.